Hello guys, welcome to Ramta Solutions. Welcome to Organic Molecules series. Today our lesson focuses on alkanes. This is all you need to know about alkanes. So, as you can see here, alkanes are saturated hydrocarbons that means they have single carbon-carbon bonds. All right. So let's proceed. This video, how is it structured? First things, we are going to look at what are alkanes. We are going to give you a brief of alkanes. Then proceed to the naming of alkanes. Of course, what the IUPAC recommends for you to do in order to name alkanes. Then we conclude this video by drawing and naming structures of alkanes. So the third aspect of this video will be examples. Right. Okay, so what are alkanes? In the opening slide, I said to you they are saturated hydrocarbons. Of course, that means they have single carbon-carbon bonds, right? And these guys are unreactive, guys, okay? They are unreactive. We're gonna elaborate on this when we talk of physical properties of organic molecules, okay? When we name alkanes, their name ends with ane. This is why you have a compound called methane. You remember that gas? Methane. It is one of the compounds that we find under alkanes. Okay, so alkanes, their name ends with this ane. Okay, their name ends with ane. That is their suffix. All right. Now their general formula is CnH2n plus 2. Okay, remember carbon, one of the properties of carbon is that it has 4 bonds. Okay, it has 4 bonds. So you can imagine now 4 bonds. If your carbon is 1, how many hydrogens will you have? You will have 4 hydrogens. So the N that you're seeing here, this N is number of carbons. Okay, this N is number of carbons. Okay, it is number of carbons, and of course you start from 1. Right. Okay, now because these are saturated, remember guys, to say saturated is to say you are full. Okay, because you are full, we need to reduce you. And what do we do in chemistry? To reduce is basically to eliminate. Of course, even in simple English, it's to eliminate. And therefore, that means they undergo elimination reaction. And of course, substitution. But I don't want to say substitution. I say substitution cautiously. So let's remove this substitution. Let's simply say they undergo elimination reaction. Okay, let's just say they undergo elimination reaction. Okay, they undergo elimination reaction. Okay, they undergo elimination reaction. Okay, so these alkanes, guys, they are non-polar molecules. And by saying they are non-polar molecules, this means they are held by dispersion forces. Okay, this means they are held by dispersion forces. We are not going to talk much about this. However, when somebody talks of dispersion forces, you do recall intermolecular forces from grade 11. But for now, hold on. We are going to cover this in a video on physical properties of organic molecules. Okay, stay tuned. Now, one thing that you need to know, alkanes can be straight and can be branched. You're going to see the difference between them later. What is straight and what is branched? You're going to see that later. Okay, you're going to see that later. All right, perfect. Now, when they are straight, they have higher boiling points than when they are branched. But this we're not going to discuss a lot or in detail right now. We're going to discuss it later in that video of physical properties. All right. So yes, we did say that yeah, the straight ones have higher boiling points. Now I also want you to know this: as the molecular size of an organic molecule increases, okay, as the molecular size of an organic molecule or any molecule increases, melting and boiling points increase. But because we're talking organic molecules, let me put it to you in this way: as the molecular size increases, boiling points and melting points increase. Okay, so I don't really want to say larger alkanes have higher boiling points. I just want to summarize it by saying as molecular size of organic molecules increase, boiling points and melting points increase. Okay. Alkanes, guys, we have seen them, we know them a lot. For example, we use them as a source of fuel. Okay, we use them as a source of fuel, but for that aspect, let me introduce you to the uses of alkanes. How have you seen alkane? Have you seen this thing, an octane booster? Yes, there is an alkane in action. Okay, it is an alkane in action. What about gas cooking? Yes, that fuel that you use for gas cooking, it is an alkane in use. For example, this is liquefied butane. Okay, this is liquefied butane. That is an alkane in use. What about candles? Oh yeah, candles. Those are application. This is an application of alkanes. Your fuel, isn't it? Your fuel, guys. Octane rating. That is your application of alkanes. Lastly, anti-corrosion spray. That is also an application of alkanes. Okay, it is an application of alkanes. Now, let's cross over to how do we name alkanes. And this part you will see in almost all the videos of the different homologous series that we cover in grade 12. Okay, so when it comes to naming organic molecules, we follow the system that is encouraged by the IUPAC, which is the International Union of Pure and Applied Chemistry. They say when you name alkanes, one, recognize the functional group. What is the functional group of alkanes? Do you remember? The functional group of alkanes are single carbon-carbon bond, right? Single carbon-carbon bond, right? It is a single carbon-carbon bond. That is the functional group, right? It is the single carbon-carbon bond, isn't it? It is the single carbon-carbon bond. That is the functional group, isn't it? You need to recognize it. But remember, guys, your organic molecules can have more than one functional group, right? Oh yeah. Now, you find the longest continuous carbon chain. What does it mean? It means maximum number of carbons. Okay, maximum number of carbons in that molecule. Okay, maximum number of carbons in that molecule. Find the maximum number of carbons in that molecule. Then you're gonna start numbering. When you number, begin with the end nearest a substituent. In the previous video, we defined what a substituent is, isn't it? You begin numbering with the end nearest a substituent. Your substituent for alkanes will be alkyls or halogens, isn't it? Oh yeah. And then name your substituents. I did say for alkanes, your substituents are alkyl groups or halogens, right? Now, when you write the name of your molecule, begin with the number of the carbon where your substituent is found. If your substituent is found on carbon 3, you will say 3, let's say it's methyl, you will say 3 methyl. Okay, just like that. But this part you're going to see later. Begin the name with the number or numbers of the carbons to which each substituent is bonded. Finally, when you have two or more substituents, you need to list them alphabetically. Okay, you need to list them in alphabetical order. Now, if you have two or more substituents of the same kind, use prefixes di, tri, tetra, penta, and so on. Okay, if you have two methyls in a molecule, you will say dimethyl. If you have three, tri, four, tetra, and so on. Okay, perfect. Now, let me remind you, remember we said the suffixes of alkanes are anes. Alkane with one carbon. Remember, these are longest chains. With one carbon, it's called methane. With two, ethane. With three, propane. With four, butane. With five, pentane. Six, hex, of course, but because it's an alkane, hexane. Seven, which is hept, but because we're looking at alkanes, it'll be heptane. Eight, octane, right? Octane. So we end at 8, guys, for you, but the molecules are larger than this. This is for simplification, just to restrict it to this 8, because it's introduction, basically. All right? This is introduction. Okay. Now, I want you to remember this. The first 4 alkanes are gases at room temperature. I repeat, the first 4 alkanes are gases at room temperature, and the rest are liquids. And of course, as the number increases, they will become a bit waxy, right? They will become a bit waxy, which we can call solid, right? But they will be, we can still classify them as liquids, but I'd rather say a bit waxy. So the first 4 are simply gases at liquid temperature, and the rest are liquids at room temperature. Okay, when I say the rest, I want to restrict you to only 8 alkanes. So 5, 6, 7, 8 are liquid at gas temperature. Okay, now let's look at the substituents. You remember, substituents, in place of hydrogen, what do you have? You have these guys. Okay, and I will show you what I mean. For example, when you look at our substituents, they are like, you don't have your, it's your alkanes, but with one less hydrogen. Okay, with one less hydrogen, with one less hydrogen. If it had 4 hydrogens, you're gonna call it methane. If it has CH3, you're gonna call it ethane. CH3, CH2, CH3, you're gonna call it propane. But because it has one less hydrogen, you call it methyl, ethyl, propyl. Okay, and then there's this one here. If it was CH3, CH2, CH2, CH3, you're going to call it butane. But because this one is CH2, you call it butyl. You do realize that we have propyl and isopropyl. With propyl, the carbon chain is bonded to the last carbon here. But with isopropyl, the carbon chain is bonded to the central carbon. Okay, that is the difference between them. All right, perfect. Now with halogens, of course, these are your great group 17 elements: fluorine, chlorine, bromine, iodine. What happens when you are in organic chemistry? This iron part becomes oro, becomes O, 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 O. Okay, fluorine becomes fluoro. So what I'm saying is that IN becomes O, chloro, bromo, iodo, and so on. Okay, the iron become O. Okay, oh yeah. Now let's get to our examples. The first example that I'm going to give you guys is this one. Let's try to draw this molecule. Maybe I should squeeze 2 in this page. 1, 2. Let's see, what is this? How many carbons? First thing first, what is the functional group? Single carbon carbon. So this is an alkane. So the name will end with ane, isn't it? Okay. How many carbons do we have? 2. When we have 2, the name is F. So this is ethane, isn't it? This is ethane. Isn't it, guys? This is ethane, isn't it? This is ethane. All right. This is ethane. It doesn't have any substituent, so we are good. Okay, good. Now let's try this one here. This one here. How many carbons do we have? We have 1. This is methane. Okay, this is methane. Okay, now I want to draw the condensed structural formula of this guy. It is CH3, and the second one also has 3 hydrogens. Happy? This one, of course, it's CH4, right? It's CH4. Okay. Now you remember we had ethyl. Go check it out. Ethyl has 1 less hydrogen. Do you see it? It was CH3, CH3. But check, when it's ethyl, it's CH2. Happy? Perfect. Now, let's then try a second one. Let's draw this one here. I'm going to draw its structural formula. Maybe let me say, no, pentane. Let's draw the structural formula of this guy. Pent means 5. Ane, it means its functional group. It's a single carbon-carbon bond. So we need to draw 5. Right? We said it's pentane, so it's single bonds in between, isn't it? Okay. Hydrogen. I know it's tiring, guys, to be writing so many H's, but e-job. Right? Now, this is pentane. Can you see? 1, 2, 3, 4, 5. What is the condensed structural formula? It is CH3. This one has how many hydrogens? 2. Followed by 1 with how many hydrogens? 2. Again, 2. Lastly, 3. This is the structural formula. Now, what is its molecular formula? How many carbons? 5. How many hydrogens? 6. Sorry, 3, 6, 12. 12, right? And you remember the general formula was CnH2n plus 2. You can simply say, oh, 5 carbons. Okay, so it'll be 2 times 5 plus 2. Then it'll be C. Oh, come on, buddy. It'll be C5H12. Isn't this what we got? Indeed it is. Do you see this? So this is a molecular formula. And this is condensed. This is structural. Happy? Good. Now, let's try this one here. Let's draw 3 ethyl. Do you see this? Dash 2 dash methyl pentane. So, first thing first, what is the functional group? Single carbon-carbon bond. That is the homologous series alkanes. What is the longest carbon chain? Pent. Pent means you have 5 carbons. Pent means you have 5 carbons. Isn't it? Pent means you have 5 carbons. Now, you can see there are 2 different substituents, but all of them are alkyls. but one is ethyl, the other is methyl. So it's up to you to start numbering from the left or from the right. I will start from the left, so meaning it'll be okay, let me put this ethyl here, methyl rather. I'm going to put this methyl here, right? And then another substituent, where is it? It's ethyl at carbon number 3. Remember, you start numbering at the end nearest the substituent. Okay, at the end nearest the substituent. So when you look at it, if you are to start numbering from here, it's really not going to work. Ooh, this is ethyl, guys. This is ethyl. My bad. This is ethyl. This is supposed to be ethyl. Ethyl. Was depends what? Okay. Ethyl. Okay. So this is it. Now let me show you how you number. Remember, it's your choice to say, let me see, 1, 2, 3, 4, 5. Where's the first substituent? On the third carbon. No, I'm not going that route. But check. 1, 2, 3, 4, 5. Where's the first substituent? On the second carbon. Which one comes first between 2 and 3? It's 2. So we start numbering from here. And by the way, even if you have gone this route, you are still going to be okay. Okay. So this is your structural formula of 3-ethyl 2-methyl pentane. What is the condensed structural formula? It is CH3. Can you see it? CH, open bracket, CH3, CH, open bracket, CH2, CH3, close, CH2, and then CH3. Sorry, I'm squeezing it. Okay. CH2 and then CH3. Happy? This is your 3-ethyl 2-methyl pentane. Happy? Perfect. Now we are going to try this one here. Should I write it? Okay, let me draw its condensed structural formula and name it after CH3 CH open bracket CH3 close bracket CH2 and then CH3. I'm going to draw its structural formula. Already we know the name. So this will be first carbon has 3 hydrogens followed by a carbon with 1 hydrogen and a CH3 followed by a CH2 followed by a CH3. How do we start numbering? Let's see. 1, 2, 3, 4. That's the longest chain. 1, 2, 3. So the longest chain has 4 carbons. Do we start numbering from the left or from the right? Let's see. The first substituent, 1, 2, 3, 4. It's on carbon 2. If we go this route, 1, 2, 3. Okay, no, we must start from left to right. So the name will be longest chain is 4 carbons, which is bute. Okay, but where's the substituent? Is on the second carbon. Can you see that? What is the name of the substituent? Methyl. And what is the longest chain? We said bute. What is the functional group? Single carbon-carbon. Which homologous series is that? Alkane. So it's 2-methyl butane. Okay. Now, I want to show you something. This molecule, guys, when you look at it, it has how many carbons? 5, isn't it? And therefore, how many hydrogens? 12, isn't it? 5 and 12. We have looked at one like this earlier. Do you remember? This is a straight chain, and this is a branched. So this one has a boiling point lower than the other one. So this has a higher boiling point. Okay. What do we call this? Pentane has a higher boiling point than 2-methyl butane because this is branched. This is what we mean by branched. Okay, guys? This is what we mean by branched. Okay, guys. All right. Now, let's try this one here. Oh, it's going to be interesting. Oh, and this one, honestly speaking, when I draw it, I get bored along the way. I'm being honest, guys. I get bored. I'm sorry, sometimes my C is a bit small. I'm just trying to save some space, but I don't like that. Okay. All right. So first thing first, recognize the functional group. What is the functional group here? The functional group is single carbon-carbon bonds. Which homologous series is that? Alkanes. Now, what is the longest chain? Let's see. 1, 2, 3, 4, 5, 6. 6. Wow, that's interesting. 6. Okay, 6. So it means we are expecting a hex. Now, where do we start numbering? 1. Is it 6 though? 1, 2, 3, 4, 5, 6. Okay, it's 6. Where do we start numbering? 1, 2, 3, 4, 5, 6. Okay, I see disturbance at carbon 2. 1, 2, 3. Okay, from the left, guys. We start numbering from the left. Okay, we start numbering from the left. It'll be I know this is a video you guys are following. So it'll be 1, 2, 3, 4, 5, 6. Where's the first disturbance? Carbon 2. They are the same. So as I see, they are all methyls. So it's at carbon 2, again at carbon 2, and then at carbon 4. Do you see this? 2, 2, because it's 2 methyls at carbon 2, and then again at carbon 4. What is it? Oh, they are 3 of the same kind. It's trimethyl. The longest chain was 6 carbons, hex. And the homologous series was alkanes. So it is hexane. So this is 2, 2, 4 trimethyl hexane. Happy? Oh, yeah. Oh, this is nice, guys. This is nice. Now, let's try another one. Oh, I don't like this one, but it's fun. Honestly, it's fun. So let's see. It'll be C. Allow me to draw it like this. CH2, CH3. Okay. Okay. Let me draw an alkyl here. Perhaps let me add a carbon here. Okay. First thing first, recognize a functional group. Single carbon-carbon bond. What is that homologous series? Alkanes. Okay, cool. What is the longest chain? I think here I should add a CH3 as well. Let me add a CH3 here, just to make it interesting. Ooh, Azish. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, we are going to deal with 7. which is hept, right? We are going to deal with 7, which is hept. How do we start numbering? Do we move from left or right? 1, 2, 3. 4, 5, 6, 7. Okay. 1, 2, 3. Okay. We're going to start numbering from the right, isn't it? So it's going to be 1, 2, 3, 4, 5, 6, 7. Okay. 7. So what is the name? The name will be, this is, by the way, before I proceed, this is ethyl and this is methyl, right? This is ethyl, this is ethyl, and this is methyl. Where are they? EM, which one comes first? Ethyl. So where is it? Carbon 5. So this is 5 ethyl. And where is the methyl? On carbon 2. 2 methyl. What is the longest chain? We said it has 7 carbons. And because it's an alkane, it'll be methyl heptane. Okay, methyl heptane. Let's do the condensed structural formula. It is CH3, CH2. It's not a mistake, guys. CH3, CH2, CH, open bracket, CH2, CH3, CH2, CH2, CH, open bracket, CH3, this part here, and then CH3. Do you guys see this? Oh yeah. Even if you would have started here going that way, it was still okay. All right, guys? Oh yeah. And this is your structure, or rather, this is the name of the structure: 5-ethyl, 2-methyl heptane. I think I should try another one. Yeah, I think I should try another one. Let's try this one here, guys. Let's try CH3, CH, open bracket, I, close, CH3. Now, what is this? Iodine. The longest chain is 3 carbons. This looks like single carbon, so it'll be 2 iodo-propane. But let's draw the structure. 1 with 3 hydrogens. The central has a hydrogen and an iodine. The third has 3 hydrogens. Now, the longest here is 3 carbons, so 3 is prop, isn't it? And the homologous series is single carbon. Sorry, functional group is single carbon. Homologous series is alkanes. Now, where is the substituent? On carbon number 2, what is it? Iodine. So it becomes iodo. So it's iodo-propane. Okay, it becomes iodo-propane. Ooh, guys, we have done enough, isn't it? With that being said, I would like to say, re a leboga. Thank you. Asante. Rolibu. And enkosi. So, see you next time when we look at alkenes. Alright, so see you next time when we look at alkenes. So with that being said, ours ends here. And remember, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. You can also follow us on the social media platforms. With that being said, it's a wrap and bye-bye.